Hello everyone, good morning. I welcome you all to our video lecture series which is based on difference equation part 1 and if you are watching our video lectures so you must have know that this is our ninth video and previously we have completed some topics in the 8 videos. Okay, so we will see today the last article of the first unit, and that is generating functions and the approximate summation. Okay, so previously we have discussed some main topics, so let's see, just we are overlooking. So first one was difference operator, that is delta. Second one was some fundamental properties of delta and some basic definitions, or you may say some formulas. Okay, and third one was falling factorial power and some basic theorems related to this. Then next one was summation. डिफरन्स ऑपरेटर होता आपल्याकडे आणि त्याचा जो रिव्हर्स प्रोसेस आहे तो आहे समेशन. ओके, डिफरन्स ऑपरेटर आपण कन्सिडर करतो ना डेरिव्हेटिव्ह आणि इंटिग्रेशन. सो डेरिव्हेटिव्हच्या जागी आपल्याकडे डिफरन्स ऑपरेटर आहे आणि इंटिग्रेशनच्या जागी आपल्याकडे समेशन होतं. ओके, सो समेशन अँड इट्स प्रॉपर्टीज अँड सम थिअरम्स. ओके, अँड नेक्स्ट वन वॉज सम IMP theorems which was related to definite and indefinite sum. Then we have seen the Abel's summation formula, and today our topic is generating functions and the approximate summation. Okay, so let's start with the today's topic. So our topic is generating functions and the approximate summation. So what is generating function? So generating function is, we can say, any function which generates the other function is known as a generating function. Means जो कुठल्याही फंक्शनला जनरेट करत असेल एखादा फंक्शन, त्या फंक्शनला आपण म्हणू की हा जनरेटिंग फंक्शन आहे. ओके, सो आपल्याला शिकायचं आहे जनरेटिंग फंक्शन. सो डेफिनेशन आहे, let ykt be a sequence of functions. Okay, ykt is a sequence of functions. First one is, if there is a function gtx, so that gtx equals to summation from k equals to 0 to infinity ykt into x to the power k for all x in an open interval about 0, then g is called the generating function for ykt. So first one is a generating function for ykt. So what is the concept of generating function? Okay, this gtx can be said as a generating function of ykt. The gtx will be considered as a generating function of ykt, that is a sequence of function, if this gtx can be expressed as the summation from k equals to 0 to infinity ykt into x to the power k. हा gtx जर आपल्याला एक्सप्रेस करता आला या समेशनच्या फॉर्ममध्ये, तर आपण काय म्हणू की gtx हा काय आहे, जनरेटिंग फंक्शन ऑफ ykt. So this summation of the power series, okay, this gtx if expressed as the summation of this power series, then this will be considered as the generating function for the sequence ykt. So हा जो ykt आहे हा कशा फॉर्ममध्ये लिहिला जाईल, equals to if k equals to 0, we are putting k equals to 0, so y0 of t x to the power 0, that is 1, plus y1 of t into x plus y2 of t into x square plus up to so on. So this is the expression for power series, which is for x equals to 0, because it is about the 0, that is the origin. Okay, so if we are putting k equals to 0 to infinity, we are getting like this, and we can write it also like a0 plus y1 t च्या जागी a1 into x plus a2 x square and plus up to so on. So y0 of t plus y1 of t into x plus y2 t x square plus up to so on can be write it like this. Okay, and this can be written as summation over an and x to the power n. So n equals to 0 to infinity. Okay, so this is for the power series around x equals to 0. Okay, and an will be the coefficients of this power series. Now we can also say this gtx can be said as the generating function if these ykts, suppose we are putting k equals to 1 2 3 4 and up to so on, so that ykts can be write as the coefficient. Okay, या पॉवर सिरीजचा कोइफिशियंट म्हणून आपल्याला जर का वाय के टी एक्सप्रेस करता आले तर आपण म्हणू की जी ऑफ टी एक्स इज द जनरेटिंग फंक्शन ऑफ वाय के टी. ओके, सेकंड वन इज द एक्सपोनेन्शियल जनरेटिंग फंक्शन. ओके, सो second definition is if there is a function h of tx, इथे आपल्याजवळ होतं g of tx, g of tx ला म्हटलं होतं आपण जनरेटिंग फंक्शन. आता आपल्याला काय आहे h of tx आणि h of tx ला आपण काय म्हणणार आहोत एक्सपोनेन्शियली जनरेटिंग फंक्शन. सो हाऊ if there is a function htx, so that htx equals to summation from k equals to 0 to infinity ykt into x to the power k by k factorial for all x in an open interval about 0, then h is called the exponential generating function for ykt. जर h of tx याला एक्सप्रेस करता आलं या फॉर्ममध्ये, that is summation from k equals to 0 to infinity ykt into x to the power k upon k factorial for all the x in an open interval about 0. सेम आहे इथे पण 0 साठी आणि इथे पण 0 साठी. Then this htx, that is this h, is called the exponentially generating function for ykt. Here gtx was the generating function and this h is the exponentially generating function. That is your htx, this htx must be written in the form htx equals to, we are putting k equals to 0 to infinity. So for 0 it will be like y0 of t x to the power 0, that is 1 and upon 0 factorial plus y1 of t into x to the power 1 x to the power 1 upon 1 factorial, then plus y2 of t x square by 2 factorial and plus up to so on. So if we are writing h of tx as in this form, so we can say that this is called the exponentially generating function for ykt, such that g of tx equals to y0t plus y1tx plus y2t x square and plus up to so on. इथे आपण जसं पाहिलं ना y0t y1t सेम आपण इथे लिहिलेलं आहे. ओके, सो हेच आपल्याला या फॉर्ममध्ये लिहिता येईल a0 plus a1x plus a2x square, and this can be also written as a summation an into x to the power n. Now for each t ykt is the kth coefficient. Okay, प्रत्येक t साठी ykt हा काय राहील kth coefficient राहील. सपोज आपण kth coefficient पर्यंत पोहोचलो तर इथे काय येईल yk of t x to the power k. So this yk will be the kth coefficient in the power series. Correct. So हा y0 of t काय राहील आपला 0th coefficient, y1 राहील फर्स्ट कोइफिशियंट, y2 राहील सेकंड कोइफिशियंट, अँड अप टू सो ऑन k पर्यंत आपण गेलो तर हा काय राहील kth कोइफिशियंट. Okay, so for each t, by kt is the kth coefficient in the power series for gtx with x at x equals to 0. आणि आपण जर जनरली फॉर्म्युला फॉर्म केला तर आपल्याला काय मिळेल, वाय टी इक्वल्स टू 1 बाय के फॅक्टोरियल del k by del x k g of t0 and yt equals to del k by del x k h t0 if we are putting x equals to 0 in this and this. Okay, so this was our generating function and the exponentially generating function. Okay, I hope so you all have get it. So we will see the example on it. So the question is, compute the generating and exponential function for ykt equals to f of t to the power k. आपल्याला काय काढायचं आहे, मग जनरेटिंग फंक्शन काढायचं आहे आणि एक्सपोनेन्शियली जनरेटिंग फंक्शन काढायचं आहे वाय के टीचं. आणि वाय के टीची व्हॅल्यू काय आहे, एफ ऑफ टी टू द पॉवर के. सो सोल्युशन पाहूया. We have gtx equals to summation from k equals to 0 to infinity yk of t into x to the power k. आता हा आपला फॉर्म्युला झाला. ओके, आता आपण yk t ची व्हॅल्यू पुट करूया. सो summation from k equals to 0 to infinity yk t is f of t to the power k into x to the power k. Okay, and this are in multiplication. So f of t into x आणि k कॉमन इंडेक्समध्ये. सो समेशन फ्रॉम k इक्वल्स टू 0 to infinity f of t into x to the power k. And by solving this we get first 1 plus f of t into x plus, if we are putting 0 we are getting 1, if we are putting 1 we are getting f of t into x to the power 1 plus f of t into x to the power 2 and up to so on. But this is the series for 1 by 1 minus f of t into x. So this is f of t into x. If this is less than 1 then only we can write it like this. If this is not less than 1 this is not correct. Okay, and this is our required generating function for f of t to the power k. ठीक आहे. सो g of tx मिळाला आपल्याला 1 बाय 1 मायनस एफ ऑफ टी इंटू एक्स आणि हा झाला जनरेटिंग फंक्शन. आता आपण h of tx ची व्हॅल्यू काढू. सो h of tx इज व्हॉट, summation from k equals to 0 to infinity ykt into x to the power k by k factorial. Now we are putting the value of ykt. We are getting summation from k equals to 0 to infinity f of t to the power k into x to the power k. Same solve करत जायचं आहे. Summation from k equals to 0 to infinity f of t into x to the power k upon k factorial, and this is the series for e to the power f of t into x. Okay, so h of tx ची व्हॅल्यू मिळाली e to the power f of t into x. So this is the required exponential function for f of t to the power k, and this was the required generating function for f of t. So this is the generating function and this is the exponential generating function. Now we will solve one another example. So for that we will take yk equals to 1, that is yk of t is equals to 1, y0 of t will be 0 and y1 of t equals to 1, y2 of t equals to 1. So for finding g of tx, the formula is summation from k equals to 0 to infinity yk of t into x to the power k. Okay, so this is the formula, and we will have to put yk of t, that is equals to 1 for summation k equals to 0 to infinity, y1 of t will be equals to 1 and x to the power k. All these values will be equals to 1. Okay, so 1 into x to the power k, that is equals to summation from k equals to 0 to infinity x to the power k. And how we will solve this? We are putting k equals to 0, 1, 2, 3 and up to so on. So if we are putting k equals to 0, what we get? X to the power 0, correct? X to the power 0 plus x to the power 1 plus x to the power 2 plus up to so on. So that is 1 plus x square plus x to the power 1 x square plus x cube plus up to so on. Okay, and this can be written as 1 by 1 minus x, correct? This series can be written as 1 by 1 minus x, and this x should be mod x should be less than 1. Okay, so 1 minus 1 by x is our generating function for yk equals to 1, and now we have to find the h of tx. Okay, so for h of tx, what we have to do? What is formula? Formula is summation from k equals to 0 to infinity yk t into x to the power k by k factorial, correct? This is the formula, and we have to solve by putting yk equals to 1. So summation from k equals to 0 to infinity, and yk t ची value आहे 1. So we are getting x to the power k by k factorial. Okay, and if we put k equals to 1 2 3 0 1 2 3 up to so on, we get 1, then x to the power 1 by 1 factorial, that is x, plus x square by 2 factorial, then x cube by 3 factorial plus up to so on. Okay, and what is the series for this? It can be written as the e to the power x, correct? This is the form for e to the power x, and this is our h of tx. So this is the exponentially generating function, and this g of tx, that is 1 upon 1 minus x is the generating function, and this is the exponentially generating function. Okay, so this is the example for simply generating an exponential generating function. So next is the example for finding the generating and the exponentially generating function. So first one we have seen, just I have written this. Okay, so this was for yk equals to 1, and our first question is just same like that. Okay, so yk of 1 equals to, these are the gtx and the htx we have seen earlier. Okay, now the second one is y2i equals to minus 1 to the power I. Okay, so for that gtx will be equals to summation, this is our formula, summation from k equals to 0 to infinity ykt into x to the power k. आता आपल्याला k च्या व्हॅल्यूज पुट करायचे आहे आणि ykt ची व्हॅल्यू काउंट करून gtx ची व्हॅल्यू फाइंड आउट करायची आहे. ओके, सो इफ वी पुट k इक्वल्स टू 0, we are getting y0 of t plus y1 of y1 of t into x plus इथे काय येईल y2 of t into x square plus up to so on minus alternate signs येतील. ओके, so 1 minus x square plus x to the power 4 minus x to the power 6 equals to 1 minus x square plus x to the power 4 minus x to the power 6. So what is this? It can be written as 1 by 1 plus x square, and same for the h of tx. Okay, so h of tx will be equals to 1 minus x square by 2 factorial minus x square by 4 factorial सेम अशी सिरीज वाढत जाईल. सो दिस इज द व्हॅल्यू ऑफ जी टी एक्स अँड दिस इज द व्हॅल्यू ऑफ एच टी एक्स. ओके, अँड द रिमेनिंग टू, दिस third and fourth are the homework for yourself. सो फर्स्ट आणि सेकंड मी सॉल्व केलं आहे, थर्ड आणि फोर्थ तुम्हाला सॉल्व करायचं आहे. ओके, सो दिस इज डन फॉर टुडेज लेक्चर अँड वी विल कंटिन्यू in the next video with the next topic. Okay, so the next topic will be Bernoulli's polynomial and Bernoulli's number. So this is our last topic of this unit, and in the next video we are dealing with it. So after that we are completing our first unit, and then we had to start the second unit. Okay, so till then, thank you so much.